We proceed in summation to integral calculus. Summation to integral calculus, the topic in which we are proceeding the discussion with. Okay, what example? We will straightforward. We will go to the statistics. I'm sorry. Straightforward, we will go to the case study. The case study, the example what we had taken. So we will proceed in that example. What is the example that we are working upon? So example upon which we are working right now is the if I have n number of coin and I throw it. Concept is break your problem into n different parts. Solve part by part and then assemble it rather than solving in one go. That is one thing. When you assemble it, it is called summation. This is what we are saying. Summation to integral calculus. When you assemble it, if I have a problem and divide the problem into n parts, solve the problem part by part and then assemble all the n parts. While assembling into n parts, people sometimes they feel that this is not a justice. This is not the exact solution what I was looking for. Why it is not the exact solution? Because n tends to infinity, otherwise it is an approximation. So first is dividing problem into n different parts. Solve part by part, then sum it. This is called summation. Sigma I equal to 1 to n. That is I is part number 1 to n. All the parts, sigma means summation. All the part you sum it. And if you feel that n should be infinity, because otherwise it is an approximation, then we go with the integral calculus. Okay, this is the concept. We can use vector here also. Where is the chance to introduce vector here is calculating the one part. If I divide into n part, what about calculating the one part? Because calculating the any one part is very crucial because it starts, a solution starts from there only. Calculating the one part calculating solution actually starts from there. Okay, if that is the case, then there we can use a vector. We can use vector to calculate any ith part. If I divide into n part, then assemble it. Okay, now assembly for the n unit, because we have divided into n different unit, we have to assemble all the n unit. Now if n tends to infinity, why it is infinity, that we will talk about it. Then it will come to integral calculus. That's it. Okay, so we will talk about nuance, means intricacies, while converting it to the intricacy that anyone would see while converting the repeated summation into integral calculus. Why we need summation? What is, we have taken one example. Consider there are n number of coins. Coins are in n number. I throw it. There are n number of coins. Okay, so there are n number of coins. There are n number of coins and I throw it. What I have to do is I start counting from the first coin. When I throw it, consider it comes in a line. In a straight line, all coins fall. I start with the first coin, your head or tail. If it is head, then I generate randomly a number between 0 and 1 and I write on a paper and paste it on the head. Make sense? There is a number between 0 and 1 that I have to select randomly. That number can be any fraction. So, number between 0 and 1 are infinite. Number between 0 and 1 are infinite. Okay, in that fashion, 0 and 1 number is infinite. In that section, I have to take the any number from there. If it comes as head, get that number, paste on the coin that is head. Now see what is next. Again it is head. Go again and select a number randomly between 0 and 1. Take down that number on a paper and affix it on head coin again. Then see next. Consider next is coming at tail. Go and get a random number between 3 and 4. Select any random number. Note it down and affix on the tail. So on the all the tail, on the tail, all the tails get a number randomly between 3 and 4. Note down on paper and paste it. If it is coming head on all the heads, take a number randomly between 0 and 1 and then get it and fix on the head. Now from left to right, all the coins, they have now a number on their face. Add all the numbers and tell me what it is. That is the question. Okay. Tell me what it is. Now we have, okay. Now what is the solution? What is the solution for it? Oh, yeah, I know the solution. What do you know? Okay, what is the solution? Solution is, can you tell me that on an average how many heads I would get? That you have to tell me. Okay, I'll tell you. If there are n number of coins, if I throw, then I throw many times, many times. Then if I average the number of head, sometime it will come 0 head, sometime it will come n head, sometime it will come k head, sometime it will come x number of head, like that. If you take average of it, then how much it will come? Then this proves that on an average, that many heads will appear if I throw in a random. Okay, that number of head, with one head, if it comes head, then you go and select the number between 0 and 1 randomly. Now tell me, what is the average number you will get between 0 and 1? If you try many times, what is the average number you will get? Okay, now average number of head is considered k, and average number you will get between 0 and alpha, 0 and 1 is alpha. Okay, then k into alpha, k into alpha is the net I get from the head. What about tail? If head is k, then tail is n minus k. Now for tail, I am going to get a number between 3 and 4 randomly. Try to get the average number you can expect between 3 and 4 if you select many times. Okay. Now that average number multiplied by n minus k. Consider that average number is beta. Then the net is alpha into k plus beta into n minus k. This is what you will get. Thank you very much. Okay, now question is arising, what is alpha and what is k? K is average number of head and alpha is average number I can expect if I draw randomly between 0 and 1, and beta is the number I can expect if I draw randomly between 0, 3 and 4. So k alpha beta if I get, then k into alpha plus beta into n minus k, that is the number of tail. I can tell this much you will get on average, because these are estimation only. So with the average we can estimate this, that this is what you are going to get. Thank you very much. Now tell me, what is k? What is k? What is average number of head? Average number of head. Okay, we'll go back to our original example of a classroom. In a classroom, n number of students are sitting and they have secured marks in examination between 0 and 10. Some students, 4 students got 0 marks, 20 students got 1 mark, 10 students got have 1, 2 marks, and 5 students they have got 3 marks, like that. Okay, 30 students they have got 1 mark. That is good about the class. Okay, if I draw a graph, then this is x-axis. This is called marks axis. This is marks axis, and this is number of students. This is marks axis, and this is number of students. Marks axis, number of students. Now, if marks is 0, the number of students are 4. If marks is 1, number of students are 20. If marks is 2, number of students are 10. Marks is 3, number of students are 5. Like that, against each marks, number of students are there. Against 10 marks, there are 30 students. Okay. Now, what is the average marks of the class? That is 0 into how many students are there. 1 into how many students are there. 2 into how many students are there. That will tell the what is the power of 2 marks. Because if 2 marks 10 students have got, then I can write 2 plus 2 plus 2 plus 2 plus 2 10 times. If 20 students have got 1 mark, then it is 1 plus 1 plus 1 20 times. If 0 students have got 4 students have got 0 mark, 0 plus 0 plus 0 4 times. Like that, you have to write like this. calculate the total marks divided by the number of students, that is n, that is the average marks, or 0 into number of students, 1 into number of students, 2 into number of, mind it, this, what average you are trying to calculate? I am trying to calculate average marks. If I am trying to calculate average marks, then x-axis should be marks for which we are trying to calculate the average. We are not trying to calculate average student. Whatever we are trying to calculate, that should be x-axis. Now, instead of saying now we calculate all the multiplication. 0 into height 4, 1 into height 20, 2 into height 10, 3 into height 4, like that, 10 into height 30. If I do like this, sum it, all the plus 0 into 4 plus 1 into 20 plus 2 into 10 plus 3 into 5 plus, like that, 10 into 30. This is the total number of marks that is obtained by the class divided by n. Or instead of saying this is 4 students, I would say 4 by n students. Now it will come as probability. Instead of saying this is 4 students, I would say this is 4 by n students. This is 20 by n students. This is 10 by n students. This is 5 by n students. This is 30 by n students. Means if I add all the heights, it will come as 1. This is called probability chart. So this, what is probability of getting, what is the weight of 0 mark? Weight of 0 mark is 0 into 4 by n. What is the weight of marks 1? That is 1 into 20 by n, 2 into 10 by n, 3 into, so I believe the maximum weightage is for 10 marks because 30 by n is there. Now again add same thing, 0 into 4 by n plus 1 into 20 by n plus 2 into 10 by n plus 3 into 5 by n plus 10 into 30 by n. If you add, you will get the average mark. Similarly, I have to find average number of heads. If I want to get average number of heads, then will be x-axis will be number of head. Now when head is 0, what is the probability of getting 0 head? If head is 1, what is probability of getting 1 head? If head is 2, then what is probability of getting 2 head? What is probability of getting n number of head? What is the average head? 0 into the probability plus 1 into the probability plus 2 into the probability plus 3 into the probability plus 4 into the probability plus n plus n into the probability. Now concept is arising that what is the probability at any x? If this is x-axis, that is the head, number of head. What is the probability at any x? What is the probability of getting x number of heads? If getting one head probability is p, if I toss a coin, getting head is p, then getting tail is 1 minus p. Because p and 1 minus p, they will make 1 as probability. Because there are only two possibilities. Either it will be head or it will be tail. Consider it is not a fair coin. Then probability of getting head is p and getting tail is 1 minus p. P and 1 minus p. Okay, if that is the situation, it is like that. What is the probability of getting x number of head? Then 1, then p to the power x. Because since all are independent, all coins outcome, if I throw n number of coin, each coin's outcome is independent of other coin. So if it is independent, then one coin has probability of getting head is p, then we have to multiply x time if I want x number of head. P to the power x is the probability of getting x number of head. True. But if you get x number of head, you get n minus x number of tail also. Then tail probability is 1 minus p. 1 minus p to the power n minus x. Next, n minus x is number of tail. This is if I throw n number of coin, then getting probability of x number of head. X number of head can be, all x will be all together at the beginning, at the end, or anywhere. Okay, kind of in a sporadic manner, means in a distributed manner. That will come as NCX, n combination x, way it can be assembled. So net probability of getting x amount of head is NCX, p to the power x, 1 minus p to the power n minus x. Okay, this is typically called binomial distribution. Okay, now I have got what is the average number of head? This is head axis and this is probability of head. What is the probability of getting zero head? Zero head. Probability of getting head is NC0. P to the power 0, 1 minus P to the power n minus 0. Okay, okay, understood. What is the probability of getting x number of head? Then NCx, P to the power x, 1 minus P to the n minus x. Okay, understood. Now, if it is x number of head, then x into the probability will give this weighting. Now, I have to add, now x equal to 0, x equal to 1, x equal to 2, x equal to 3, x equal to n minus 1, x equal to n. For each x, I have to multiply x with the probability and then add it. Okay, then it will come as net probability of getting x number of head. X number of head. Okay, I'm sorry, net probability of, I'm sorry, the average number of head. What is average number of head? Average number of head will be summation, sigma sign. Summation x equal to 0 to n. Summation x equal to 0 to n. Okay, summation x equal to 0 to n, and then x multiplied by probability of getting x. Summation x equal to 0 to n, x multiplied by probability of x. Next one. X probability of x plus 1 probability of x plus 1 plus x plus 2 probability of x plus 2 plus n is number of head, probability of at the time of n, that is sigma x equal to 0, x is number of head, sigma x equal to 0 to n, x is the distance, that is number of head, x into probability of getting x heads, it will come sigma x equal to 0 to n, x nc x p to the power x 1 minus p to the power n minus x. These explanations are not there in any of the book. Anyone can try. Okay. Now this is the average number of head. Okay. Finally, I got the average number of head. Thank you very much. Okay. Now how to calculate the average number of head I get? What is the concept behind it now? If I get average number of head, then head into alpha. Alpha is the average I get if I draw a random number between 0 and 1. Okay. If I get average number of head multiplied by the alpha, that is the constant. If average number of head I am getting, then average number of tail is n minus. If average number of head is k, then average number of tail is n minus k. Okay, because total is n. If it is n minus k I know. What is k? Summation x equal to 0 to n x into ncx, that is the probability part. ncx p to the power x 1 minus p to the power n minus x. This is the average number of head, that is, I am saying altogether it is k. K into alpha. Alpha is the average random number I can withdraw from 0 to 1. K into alpha plus average number I withdraw from 3 to 4 is beta. Beta into n minus k. This is what? So k we have calculated. What about n minus k? Oh, I know what is n minus k. Okay, if I know k and n minus k, then I can proceed now. Okay, now what is the solution? The k, I'm sorry. Okay, this, I believe it is very difficult. Looks like it is very difficult. Anyway, what is the average number of head we are getting? Summation. So it will something like alpha into summation x equal to 0 to n x ncx p to the power x 1 minus p to the power n minus x. Okay, this is the number of head, average number of head into alpha plus beta summation x equal to 0 to n 0 to n. Okay, then x, if I'm talking about the tail, okay, then it will be, or if I talk in this term only, then it will be summation of x equal to 0 to n x, that is the head, x ncx ncx up. This is what head we are saying. Average number of head, how much it will be. Okay, Let's talk about tail now. This is average number of head multiplied by alpha. Average number of tail. Consider x is average number of tail. Summation beta. Beta is the average number I expect between 3 and 4 randomly selected. Beta into summation x equal to 0 to n, and then n minus, I'm sorry, then x is the distance for the tail. We are doing for the tail. If I am doing term of head only, okay, let's do for the tail. Let's consider tail we represent through y. X head we represented through x. This is tail. So right now we have alpha into summation x equal to 0 to n x into ncx p to the power x 1 minus p to the power n minus x plus beta summation y equal to 0 to n y ncy p to the power n minus y 1 minus p to the power y. This is the average tail into beta. If I talk in head term only, then it will be beta into summation x equal to 0 to n minus x. Here it was x, here it is n minus x. Make sense? N minus x. Okay, and then ncx p to the power x 1 minus p to the power n minus x. I'm skeptical about it, but this should be how is it. The first term we talked about the y, that it looks like it is more concrete. Number of head is summation x equal to 0 to n x ncx p to the power x 1 minus p to the power n minus x multiplied by alpha. This is the net value I'll get for the k number of head into what alpha I am getting plus beta into summation y equal to 0 to n y ncy p to the power n minus y, because number of tail we are calculating 1 minus p to the power y. This will give the net result. If people are not happy, then we can go other way. Other way is think about the reverse fashion. What is reverse fashion? Reverse fashion is saying if I throw n number of coin and it comes k number of head, what you will do? One is that number of head is 1, number of head is 2, number of head is 3, number of head is x. Then getting the x number of head, what is the probability? That is ncx p to the power x 1 minus p to the power n minus x. That is reverse way. Reverse way is that if you get x number of head, what you will do? Okay, we have taken example in a manner. Consider there is a dice and there are n plus 1 faces of a die. 0, 1, 2, 3, 4, n. Generally in a dice, there are 6 faces. Here we have n plus 1 faces, 0 to n. If you roll a die, then consider it will come as x. What is probability of x? I know 1 by n plus 1. Consider it is not 1 by n plus 1 then. It is a biased die. Getting probability 0 is different, getting probability n is different, getting probability x is different. Everything is different. If I throw this dice and x comes on its face, if I know this that x has come, I know what is probability of x. I know it is not 1 by n plus 1. That is a fair dice. I know what is probability of x. Now tell me what you will do. This is reverse way of going the same problem. What is x? Consider x is number of head. Means if I throw a dice, if it comes 0, means number of head is 0. It is similar as if I throw n number of coin, number of head appear as 0. If I throw the dice, these examples are not there in any of the book. Anyone can try. This is my challenge. It's not there anywhere. If I throw a dice, if it comes as x, means if I throw n number of coin, x number of head will be there. What is probability of x number of head? That I know. ncx p to the power x 1 minus p to the power n minus x, where p is probability of head for one coin, 1 minus p for the tail. So if I say what is the probability of getting x number of head, if I throw the dice, it will not be 1 by n plus 1. If die is fair die, then it is 1 by n plus 1. Otherwise, it will be anything, depends upon some function, and this is the function. ncx p to the power x 1 minus p to the power n minus x. Okay, if this is the probability of getting x number of head, then what you will do? If dice shows x, if dice shows 0, then I will dance 0 times. I'll dance for 0 minute. If it shows x, then I shall dance for x minute. I don't know, it depends. Okay, what will happen if the dice is showing any random number m? What you will do? I will run for n steps. Depends. I'll do anything. Depends upon it. Okay, then now the here answer arises if die is showing x, means x number of head has appeared. What you would do? Then x time, if head is 1, then 1 time I will draw a random number from 0 to 1. Then x time I will draw a random number from 0 to 1. Then n minus x time I'll draw a random number from 3 to 4, because the tail will be 3, n minus x. Okay, now what we are going to write? You want the average number, right? If you sum from left to right, average number, what you will get? The question is, when number of head is 0, what you will do? If number of head is 0, then 0 time I will search between 0 and 1 the average number. Then n minus 0 means n time I will search from random number from the 3 to 4. If it is x, then x time I will search, and n minus x time I will search there. Okay, let's rewrite it. We want the kind of there are we want the average count. We want average count. Average. This is the count. Average count, and this is the probability against each count. Count is I believe it is number of head. I think so. Anyway, so if oh, I'm sorry, this is the dice. This is the dice number 0 to n. Okay, if I throw the dice and it comes n, then what is the probability is vertical, and this is the dice number. What is the probability of getting n on the dice? If I know this probability, then what you will do? If n comes on the dice, means you have got n head and 0 tail. When it is x, then probability of the dice getting x I know. If I know the probability, then what you will do? What you will do? Okay, I'll multiply it with something. What is something? Okay, that's something average I want. If number of head is appearing x time, I mean if I throw the dice, then it shows x number on the dice, means x number of head is appearing equivalently. If I throw n number of coin, then x is appearing. What you will do if x comes on the dice, x number of head has appeared. In that case, I'll multiply whatever comes from 0 and 1 as a random number between 0 and 1. I will draw that random number x time, and I'll multiply with the x. First time it came something, second time it came something, third time it came something. If I know it is, then I have to, rather than trying physically, I have to know what is the average I can expect between 0 and 1. That average multiplied by number of x. This is what I will do. Then I will plus it. Then I'll go to 3 and 4 and try to get the average I'll get between 3 and 4. Average into n minus x. If I add this is what I'll do if x appears on the die. How what is that? Okay, I'll tell you what is that. That is the average I get from 0 to 1. That is alpha into x number of head, right? Alpha into x plus beta average I get beta into n minus x. Make sense? Beta into bracket n minus x. This is what I'll do if x number of head is appearing. Now sum it. Summation x equal to 0 to n, and in bracket alpha into x plus beta into n minus x, close ncx p to the power x p to the power x 1 minus p to the power n minus x. This formula is not there anywhere. People everywhere in the book, what is written, what I told earlier. Alpha into summation x equal to 0 to n x n c x p to the power x 1 minus p to the power n minus x plus beta summation of y equal to 0 to n y n c y 1 sorry p to the power n minus y 1 minus p to the power y. This is what is written in the book. This is better proof. Summation x equal to 0 to n, and in bracket what you will do and what is the probability. Okay, if I know the probability and I will multiply with the head into alpha, that is the average I'll get with the only with the head, but I want full average with the head and tail all. If x number of head is appearing, what you will do? I will do alpha into x plus beta into n minus x. Probability into what you will do. What you will do, I want that average I want. Not probability average I want. What I will do, that average I want. What I shall do, that average I want. Okay, you want that average, right? Now I treat x equal to 0 to bottom. Summation x equal to 0 to n, and in bracket what you will do? Alpha into x plus beta into in bracket n minus x. Ncx p to the power n, p to the power x 1 minus p to the power n minus x. Now I can break into n different parts and then solve it. This is something that is extremely difficult. This is solving this problem in one go. Now we will break into n different parts. Now n different part means we will do this summation for one coin only. That's it. Now then we will add for all the coin n into what I get for one part. Then it will give the same solution. Surprisingly. Okay, someone can corroborate this. It is in its hand. We are not here to do, we have done it already. This is called discrete way. Discrete way. Now, if someone is solving it, if someone is solving in one go only, then what is the solution? X equal to 0 to n. Okay, and then what we provided, that is the solution. If n tends to infinity, then also solution will be same. There won't be any difference. Because n tends to infinity, number of coin will be infinity, but solution will be same, or you can divide into coin by coin. It is not going to change. Where it is going to change? It is going to change. Their random number generation, there it makes sense. Because here I know that n number of coin maximum I can divide into n part only, not beyond that, not possible. Okay, but if I'm trying to get a random number between 0 and 1, average random number, I can calculate random number between 0 and 1, it becomes 0, 1, 0.5, 0.4998, anything. But on an average, what I can expect? If that is the case, then I can get any amount of number. It is infinite between 0 and 1. Here, if n number of coins are there, then number is fixed, n. I can divide n number of coin problem into at the least to one coin. It cannot go to 0.5 coin, 0.25 coin, 0.1 coin, that is not possible. But if I divide this into 0 to 1 into n section, n can tend to infinity. That is the problem. So coin example is called discrete example, whereas this example is called analogous or continuous example. Here, there also I am trying to get average number of head. Then with that we proceeded with the calculation. Here I want, if I want average value, expected value between 0 and 1, average value, then how I can get? If I divide into n part, I have given example this. Consider divide into two parts. I want average value, right? Two parts. This is the first part and this is the second part. If this is the first part and this is second part, then consider if I select any number that falls between in first part, then for that, since I have divided into two parts only, I have divided 0 to 1 into two part only. Two part means the value that it will show, it will be either 0.5 or 1. That is called two part. Okay, if anything, consider I close my eye and touch my hand. If hand falls in the first part, then irrespective of where it is falling, it will correspond to the first part, that is 0.5. In second part, it is 1. What is average now? What is average now? How to calculate average? I know how to calculate average. That is summation x equal to 0 to n x n c x p to the power x 1 minus p to the power n minus x. This one I know. That is the solution of calculating the or this is what is probability. I'm sorry, that looks like that is very difficult. Easiest would be what is the average distance we are getting. If I hit anywhere between in half, then I'll say distance is 0.5 because we are making discrete now. If I touch anywhere here, then I say distance is 1. The answer is if I do many times touching, every touching I have result in 0.5 or 1. This is called digital way. Tell me what is the average distance I get. Then this distance into the height. This height is ncx p to the power x1 minus p to the power n minus x. Oh, sorry, 1 minus p n minus. That we will see. Right now, in simple way, getting the half of the touch probability is 1 by 2. Getting this part of the touch probability is 1 by 2. So it will be 0.5 into 1 by 2 plus 1 into 1 by 2. That will come as 0.75. So 0.75 is the average of this line, but that is not true. It should be nearing to zero point 0.5, but it is nearing to 0.75. Let's divide into 8 parts. Now let's divide into 4 parts. This is called n. How many parts you are dividing? If I have n number of coin, I am chopping into n part, and each chop has one coin. Below that, beyond that, I cannot go. If I have a problem, this is a stick of unit length, and then I blindly I try hitting a stick at one point. I don't know where I am hitting. That is trying to get random number, hitting somewhere. Now you tell me what is the average distance from origin that I have made the hit on an average. Okay, then solution is divide the stick into two parts. That is called n equal to 2. If I hit anywhere in the first part, I say it will come as 0.5. If I hit anywhere in second half, it will come as 1. Then first half 0.5 into the probability. The way I calculated average marks of the class. Then the second part that is 1 into the probability. Then point 0.5 plus, I'm sorry, it is zero point 0.5 into zero point 0.5 plus 1 into zero point 0.5. It will come as 0.75. I think so. 0.75. That is not the average certainly. Now divide into 4 parts and see it is really different. Now this is 0.25 into, now if I chop it into 4 parts, hitting into any part probability is 1 by 4. If I chop into 2 parts, hitting in any part probability is 1 by 2. If I don't chop it at all, hitting in anywhere, then probability is 1. If I chop into 4 parts, n equal to 4, then hitting in any part blindly, out of 4, I will hit in any part that will be 1 time, means 1 by 4. Now this is 1 by 4, distance is 1 by 4 into probability 1 by 4 plus 1 by 2 into 1 by 4 plus 0.75 into 1 by 4 plus 1 into 1 by 4. If someone calculated how much it will come, 1 by 4 into 1 by 4, 1 by 16. Then 2 by 4 into 1 by 4, 2 by 16. Then it will come as 3 by 4 into 1 by 4, 3 by 16, 4 by 16, 4, 3, 7, 2, 9, 10, 10 by 16. 10 by 16 is nearer to 0.5 than 0.75 what we had calculated. Means if I chop into n part and n tends to infinity, then I am getting better result. Okay, this is different than the coin problem. Here, okay, what is the average? What is the average length? Average random number I get. Random number is a number that I get the distance from the origin, 0 to 1. If I try to get random hit anywhere, if this is a random number I get, that is distance from 0 to hit here. Okay, now to get the average random number, I divide into n part, and I think in any of the section, if I hit anywhere, it will resolve into one number 1, and then probability of that is 1 by n fixed. If I divide a number 0 to 1 into n different parts, then what is the probability of hitting a particular part? 1 by n. Then distance from here into 1 by n will give the weightage of this. Then for each section, you take the distance and multiply by 1 by n. Okay, the average distance will be summation x equal to 0 to n, x 1 by n. Makes sense? That is the probability. Probability is fixed, 1 by n, x 0 to n. Okay, that is not true because x cannot be 1, 2, 3, 4 because maximum distance is 0 to 1 only. Okay, then either I would say summation I equal to 0 to n or summation I equal to 1 to n x of the ith section, and then function of the x of the ith section, any section, function of the x or the probability is 1 by n. This is typically called mass function. Mass function, point mass, every point we have a function, every point, it is not continuous though. Okay, if someone try to calculate how much it will come, someone can try. Okay, if I is 1, then distance x distance will be 1 into 1 by n into I. So I can rather say now summation of I equal to 1 to n, 1 to n, and then 1 by n into I, that is the x distance, into 1 by n. Make sense? Whatever it comes, that will be the average length of the string. Someone will say, but it will not be perfect because n tends to infinity, then only it will be perfect because it is continuous. Okay, if that is the case, then question is arising. Now I have digital solution. What is digital solution is to get the random number between 0 and 1 where it is continuous. The digital or discrete solution is chop it into n part and then say summation I equal to 1 to n x. X is distance from the begin point of the ith section. You see the first I, second I, third I, nth I. Some distance from the 0 to the ith section. That is the I. That is the x. Okay. Now summation I equal to 0 to n. Summation I equal to 0 to n. X distance of the ith section, x distance of the ith section, and probability of any section probability is 1 by n only. Now I can write the average length or average random number I get from 0 to 1 is summation I equal to 1 to n x distance of the ith section into probability of the x, that is 1 by n. If someone proceed with this, then he can calculate the average length when I divide into n. No. Perfect would be n tends to infinity. Then no one can calculate. Not possible. How n tends to infinity? Every section he will calculate the length and one and probability. Then length that he has to do infinite times. Not possible. This is the correct scenario. This is the exact scenario where we will transform the summation into integral calculus. What about 3 to 4? What about average between 3 to 4? Then take out 3, then it will be again 0 to 1 only. Whatever it comes, add it with 3. Same. Okay, it will be 3, 3 plus, and then again same thing. I equal to 1 to n and x of the ith section into 1 by n. Okay, that will also, you have to add with the 3 because 3 to 4 is same as 0 to 1. Whatever average comes, you have to add with the 3. That's it. Okay, how to convert this into integral calculus? That is the question now. What is integral calculus? Integral calculus normal. What is summation? The summation, the normal formula is summation sigma sine I equal to 1 to n and then whatever you have. This is typically called summation sign. What is integration sign? Limit, function, and dx. fx dx is the integration. Now I have to convert summation into integral calculus. What is summation? Summation is I equal to 1 to n x of the ith section. X is the distance of the ith section. I is 1, 2, 3, 4. Ith section. And then function over x. Function over x is the probability. That is fixed right now. That is 1 by n. So x fx. Summation x of the ith section. Summation I equal to 1 to n. This I have to transform into integral calculus because n tends to infinity. That is not possible here. We go to next step only when it is not possible to us. Now in that fashion, whatever comes, that is the alpha that we kept talking. Now what is integration mode? That is summation, that is integral sign, limit sign x, not I, x begin to end because we're talking about x-axis. Here I chop into n part. There is no chopping here. N is infinity. X is begin to end. X is 0 to 1. And then gx dx. Gx is another function. So if I say whatever I'm getting summation here, I equal to 1 to n x of the ith section fx of the ith section, this should be exactly equal to integration x equal to 0 to 1, not I equal to 1 to n, x equal to 0 to 1, gx dx. What is gx and dx? If I have a if this is x-axis, this is x-axis, this is g-x-axis. If this is x-axis, then this is called g of x-axis. X-axis, g of x-axis, y-axis, g of x-axis. If there is a curve like this that is called gx, then gx dx is the area underneath this curve. Gx dx means area underneath this curve. This area need to be computed from the limit x equal to 0 to 1, not beyond that, or x equal to half to 3 half, whatever. Okay, how to get gx? That is the question mark. I know fx, that is 1 by n. I know fx, that is 1 by n. How these two computation will be same? Where things are different. I have to calculate gx now. Okay, one way to calculate gx, consider this x into fx. Consider x into fx. This is what we are calculating. Take x outside. Take x outside and it is only fx because we want gx. Fx is a function of the discrete height at I equal of the first section. If I take the if I take this line, then I chop it into n part. For the each part I have the probability. For each part I have the probability. If I connect all the top point, I get the fx. Right now fx is 1 by n, that is constant. So fx is 1 by n. If 1 by n, if I add all the fx, then it will give me the addition of the vertical bar. How to calculate? How to change x fx x into fx when x belongs to ith section, I equal to 1 to n, to limit x equal to 0 to 1 gx dx. That is the question mark now. Okay, to have it, x take it outside. Now, more or less, if I say that if I want to have summation I equal to 1 to n fxi equal to gx dx and some limit. Means if I add all the vertical bar, that should be same as if there is a gx function, its area. Makes sense? Both should be exactly same. Both should be exactly same. When it will be exactly same? Okay, if I just write like this, fx equal to integration gx dx. This is the next scenario I want. Summation of fx. Okay, summation of fx should be integration. So integration dx, I believe it will be very common. Okay, we will do in next session. Okay, the concept is that how to convert fx summation of fx means summation of all the heights, probability height as gx dx, integration gx dx. Okay, what gx dx does? gx dx integration. If gx is a continuous curve, then it will give the area underneath it. What is fx? Fx is if I chop n times, then in each chop fx is the height. Fx is the height. Addition of all the heights should be exactly same as if I take another function that underneath area is. What is addition of all the height? Addition of all the height. If I want to calculate area underneath, what is addition of all the height? Fx I can rewrite if I want to calculate the area underneath it. Okay, if I have fx, then fx can be written as fx into 1. Fx can be written as fx into 1. Okay, where 1, what is 1? Okay, I can rewrite the addition of all the vertical bar. Addition of all the, actually we are doing what is what is the width and what is the vertical bar. Multiply width with the vertical bar and then sum it. This is what we are trying to do. Okay, but net that is coming here, whether we want net actually okay, whatever. Okay, whatever we consider x into fx is another function called fx1. X into fx is another function x1. Oh, I'm sorry. Okay, idea is how to bring x into fx, summation into integral calculus, where I have another function as gx. I have to get gx in a manner that if I calculate area underneath gx dx, limit x equal to 1, it will be exactly same as whatever I get x into fx. Then next I x into fx, then next I x into fx, then next I x into fx. It should be exactly same. Okay, now, if I take the first one, that is the summation. Summation means I am taking x and then I'm multiplying with the height. Then I am taking next x in the next section. Then multiplying with the height. Okay. If I take the height, if consider that I take fx as a function. Consider that it is same as x fx dx. Consider. If can I rewrite or leave the x part for time being, leave the x part. I'm writing summation I equal to 1 to n f x of the ith section. This is the addition. Can I rewrite as fx dx integration x equal to 0 to 1? What is stopping me directly writing it as, if I have summation I equal to 1 to n, summation I equal to 1 to n f x belongs to ith section. If I is n by 2, then x will be 0.5 because I have chopped into n part. If I is the n by 2th section, then x will be 1 by 2. If I is 3 by 4 into n, then if I is 3 by 4 by n, then x will be 3 by 4. It is like that. Okay, I have summation I equal to 1 to n function over x. X belongs to ith section. Can I rewrite as integration x is 0 to 1 fx dx? No. What is stopping us? Okay. How, if I have vertical bar, can I add all the vertical bar? If I'm sorry, if there are fx in vertical bar and one vertical bar is one in one section, if I chop into n part, each part has one vertical bar, each part which has a width of delta x or width of 1 by n. This width is 1 by n and there is one vertical bar. This width is 1 by n and one vertical bar. Like that I have n vertical bar. This n vertical bar, if all top point if I connect, it becomes fx, and that is 1 by n, that is fixed. But take it as fx1. Okay, if I say I have another equation called integration fx dx, then whatever fx we have calculated, fx, if I draw this curve, curve means connecting all the top point of the fx, then fx dx will give the area underneath it. Makes sense? Okay, means we are trying indirectly, we are trying to calculate area underneath it through the integral calculus. But right now we have different scenario. What is different scenario is n can be anything. N can be anything. N can be 10 also. We have divided 0 to 1 into 10 part. Each part has some height. Okay, if I add all those height, then we will get something. If I divide in, if I make n as 100, then I have some height. If I add all the height, it will be something. Okay, if I multiply each height is fx. If I multiply each height with the width of the section, then next height with the width of the section, then next height with the width of the section, then we will come in a phase that we are trying to not add all the heights, we are trying to add all the sub area. Very complex. Okay, we'll try again. Consider this is fx. Right now, fx is a straight line. Right now, fx is a straight line that is 1 by n. 1 by n, because 1 by n is the probability of each section. If I cut 0 to 1 into n part, selecting any section, probability is 1 by n. fx is 1 by n. That is for sure. Okay, if it is 1 by n, probability of getting selecting any section is 1 by n. Then now we are trying, if I say I have fx dx, then whatever the function we have, fx dx, I'm sorry, if I go for summation, then we are adding all the vertical bar. We are adding all the vertical bar. Okay, adding all the vertical bar is same as with each bar I multiply with the 1. Make sense? Now fx, summation of fx is same as summation of fx into 1. 1 I can write as delta x, means vertical bar into 1. Hope, again confusion. I believe we'll do in another session. Okay, we'll try one more time. Okay, if this is fx is the height for each section. Fx is the height for the each section. Now we are adding all the height. We are adding all the height. Now we have summation x, summation I equal to 1 to n fx. X belongs to any ith section. Okay, now if this is this whatever we are calculating, now if I multiply this height with this width somehow, if I multiply this height with this width, height with this width, height with this width, height this with this, then we are trying to calculate the area. Any height into width will give the area. Any height into the width will give the area. Any height into width will give the area. So fxi into delta xi will give the area. Okay, right now what it is? Right now it is fxi into 1. Now let's, rather than calculating the vertical bar, let's calculate in terms of area. Area means vertical bar. Now we have n section, right? We have first section, second section, third section, fourth section, fifth section, sixth section, nth section. Each section has one height. Okay, that we are trying to calculate. Okay, if I have a height that I am trying to calculate, trying to add, can I go with adding the all the subsection area? Rather than adding all the vertical bar, can I add all the subsection area? To get the subsection area, we have to multiply height with the width. Make sense? Rather than adding all the height, let's we have another concept called adding all the subsection area. It makes an area. If I have a vertical bar in the any ith section like this, then next bar is at some distance. Next bar is at some distance. Can I multiply this height with the in between distance? The gap is there. Can I multiply with this? Can I rewrite as summation x equal to I equal to 1 to n fxi into delta xi, where delta xi is the width of the each section. You can do it. Then you are trying to add all the subsection area. Earlier you were trying to add all the height. Now you are trying to add all the subsection area. Yeah, I am trying that, but it will not be the same. With the first thing, that is the repeated summation. With the second thing, that is the integration. Integration means if you have a function, then area underneath it. Any area underneath means if you chop, if this is the function, if this is the function, called this function is fx. Fx dx means area underneath it. Area underneath is same as if I chop this area. If I chop this area into n different parts, then area of each section, if I add, that will become area underneath it. Make sense? Okay. Now there are two things. One is addition of the vertical and one is addition of the area subsection. Area subsection is vertical into the gap between two sampling. Okay. Now we have fx equal to fx dx. Both are not same. Both are not same. If I say I have fx, I have cut this x-axis into n different parts. Each part has a vertical height, and I am adding all the vertical height with summation I equal to 1 to n function over x of the ith section. Now in the second expression, what we are doing is each vertical height I am multiplying with the width of that section. Now then I am adding it. It is now we are trying to move in a way that we are trying to calculate underneath area of it. If I make an area, okay, but problem here is if both are same, fx summation fx equal to summation fx into delta x. If both has are same, it is only possible when delta x is 1. Then only it is possible. But delta x is not 1. Delta x, that is very less. If n tends to infinity, that is very less. And it comes to integral calculus. Okay, now I have to find a way that repeated addition of the vertical bar should be same as if I calculate the if I repeated addition of the subsection area. Means I have to find another bar. I have to find another bar which is called gx into delta x, gx into delta x, summation gx into delta x, where x is I'm sorry. Now there are two things now. One is summation I equal to 1 to n fxi. Okay, should be equal to summation I equal to 1 to n gxi delta xi. Delta xi is the gap of one section if I have chopped into n part. Now in second section n tends to infinity. In second section n tends to infinity. If n tends to infinity also it will not change. Even though n tends to infinity it will not change. Delta x will keep changing. If I have unit length, and I have gx as a function, okay, and then I chop into n part where n keep on changing. If I say at any point get the gx, that is the height, and multiply with the gap you have, okay, then this will give this area straight. So if n is small, then we have bigger gap. If n is larger, we have a smaller gap. Okay, we'll take gx into the gap. Okay, in that fashion, if gap is less, then area of one subsection is very small. But we have to add n times that n tends to infinity. It will always be constant. Make sense? Summation I equal to 1 to n gxi delta xi. It will be always constant irrespective of n. In fact, it will give better result if n tends to infinity. This is called integral form. This is called summation form. Summation form is summation I equal to 1 to n fxi. Integral is summation of I equal to 1 to n gxi dx. This is addition of sub area. Addition of sub area result in the big area. A big area is integration. Where here addition is here the addition of the vertical bar only. There is no concept of the in between area. If luckily in between area is 1, then directly I can convert into integral calculus. But it is not the case here. We have 0 to 1, we have divided into n part. Now I have to find a gx in a way that summation of I equal to 1 to n fxi will be same as summation I equal to 1 to n gxi delta xi, where n tends to infinity. This can be rewritten as integration x equal to 0 to 1 gx dx. Though I believe it makes more sense. If someone need to find out, someone has to differentiate fx. D of fx and differentiating here it will come as gx. Then gx will be d of fx. From there we can try. Okay, what? Okay, or so gx will be d of fx by delta xi. D of fx, but I believe from here we will proceed. This is not that straightforward. There are many researches going on to convert the digital form to analog form. If I have a digital form and I am summing for the n part, then it is not accurate. N tends to infinity. If n tends to infinity, then I cannot calculate. Not possible. N tends to infinity is only possible if I go by the sub area. That concept where you irrespective of the n, it will be same. That is called integral calculus. And in that form, I have to convert fx into gx so that net addition of all the vertical bar will be same as if I have a gx and I calculate the area underneath it, or if I add all the subsection of the area, then I have to find gx. Anyway, someone can say it is very simple. Why you are going like that? You have to do x into fx, right? Fx is 1 by n. 1 by n you can rewrite as 1 into 1 by n. 1 by n is the gap between it. So it is fx will be 1 and delta x will be 1 by n. Now you can go like this, that is x into dx. That way we'll see. Please do, I'm really sweating badly. Okay. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone.